If the notation for a function is fx, the notation for an inverse function is f to the power of minus 1 x, okay? And they're inverses of each other, they're opposites, which means the domain of fx is the range of f minus 1x, and vice versa. The range of fx is the domain of f minus 1x. Provided you know and remember that rule, you're going to find things a lot easier, because you only have to work out the domain and range of one function, and then you just apply this rule, you've got the domain and range of the inverse function as well. So let me take you through how to do inverse functions. So in this case, it says find the inverse function of fx equals 3 over x minus 1. Now here's what you're going to do. You're going to use substitution. You're going to let y equal fx. So y equals 3 over, x minus 1. And now what you're going to do is you're going to try and make x the subject of the formula. So can you try that, please? Can you try and make that x the subject? So you're going to take it to the other side, like this. You're going to expand. You're going to move that y over. And now you're going to divide. Like this. From this point, all you have to do is change the notations. So f minus 1x equals 3 plus x over x. That is your inverse function. And that's how you do it. Just use a substitute, make x the subject, and then rewrite it. Instead of y, use x, and instead of x, use f minus 1. Hope that made sense. I want you to try this question, please. Now, before you give it a go, I am being a little bit mean with this one. So, feel free to use Google to help you out as much as you'd like. Ideally, not give you the question or give you the answer. But you can use Google for this. You can use your textbook, whatever you need to get you through this question. And I'm going to go through it anyway. So can you give this a go, please? Right. So it says, state the range of fx. Ideally, you kind of want to draw fx first. It makes things a bit easier. So let's draw y equals the square root of x first. That's going to be this, okay? So if I want x minus 2, I'm basically doing fx minus 2. So I'm moving everything to the right by 2. So something like this. So now if I get rid of this red bit, this is y equals root x minus 2. It's asking for the range. The range is any value of y provided that it's greater than or equal to 0. So the range is y can be any real value. And let me redraw that. Let me try again. Hold on. There we go. Y can be any real value, and then comma, provided that it's greater than or equal to 0. Because at this point, y equals 0, and it has no limit above that. It's going to continue on going up and up and up forever. So there's no upper limit to it. Cool. Part B says, find the function f minus 1 and state its domain and range. So you're going to let fx equal y, or y equal fx. That was a really badly written x. So y equals root x minus 2, and now you're making this the subject. So y squared equals x minus 2, y squared plus 2 equals x, and now we rewrite. So f minus 1x equals x squared plus 2. We don't have to draw it again to know the domain and range. The range of f minus 1 is the domain of fx, and the range of f minus 1 is the domain of fx. Did I just say the same thing twice? Domain of fx is range of f minus 1. Range of fx is domain of f minus 1. That's the rule. So, the domain of fx is x is greater than or equal to 2, which means the range of this is y is greater than or equal to 2, and any real value. And then the domain is going to be the range. So x is greater than or equal to 0, and then again, x can be any real value. Sketch y equals fx and y equals f minus 1 and the line y equals x. So let's draw an axis. Fx looks something like this, and f minus 1 looks something like that. So f minus 1x, x squared plus 2, and this is equal to fx. Y equals x is this. Y equals x is something like that. So f minus 1 is a reflection of fx according to the line y equals x. Although it's hard to see from this sketch, if you have a look at, let's say, Google or any textbook, it's going to be a bit clearer. But there you go. That is how you do inverse functions.